Welcome back, everybody. Hope you had a good week. The first thing we're going to do is open up our Unity Package Manager, go into the Unity registry, and install Cinemachine. I'm sure you're all anxious to get into the code, but before we do that, I want to set things up inside Unity, build ourselves an actual ship so that we have something physical to test our script with once we finish it. I'm going to start by just making a cube. Everything I make here is just going to be with default 3D objects that are inside Unity's built-in stuff. So I'm going to scale this up along the z-axis. That's important because that's the forward direction our ship points. I'm going to make another cube and scale this up. I'm going to call this the body. That looks pretty good. I'll make another cube. I'm going to call this a wing. Look, this does not have to be anything fancy, right? I'm just trying to make something that looks kind of ship-like so that we get the idea when we attach the script to it and see how it works. That looks kind of cool, right? Slide this forward a little bit. I'm going to put a parent above these wings so that they're all organized a little nicer. I'm going to make a left projectile gun. I'm going to scale this down, move it over here. I'm going to duplicate it, call it the right projectile gun, and then just position it on the opposite side. Then we'll make a raycast gun. I'm going to make this a long thing. This is like our laser beam. And this is looking pretty cool. Now I'm going to make projectile launch points for each of these guns. They're just going to be positioned a little bit in front of the visual for each of these weapons. Same for the raycast launch point. And then this isn't going to be anything that's scripted, but just for the visuals, I'm going to make a left engine and a right engine. And yeah, it's looking kind of cool. Looks a little Christian coded. So maybe I'll call it the Crusader. That seems appropriate. Okay, let's make a folder called Materials. I'm going to zip through this. We're going to make a metal red material. Just put the metallic all the way up and make it red. I'm going to duplicate that and make a blue version of it. Duplicate it again and make a gray version of it. Next, let's make a material called Engine Glow. I'm going to make this orange, and I'm going to turn on the emission and make that sort of a brighter yellow glow kind of look. Let's make another new material, and I'm going to call this exterior glass. We're going to want to make this transparent, and we'll tweak that more later. Let's drag these onto our ship. So blue is going to be my projectile guns. Gray is going to be anything that's just the body of the ship. The exterior glass is going to go on the cockpit. Red is going to go on the laser beam. And engine glow is going to go on the engines. And we can make this a little bit brighter. So yeah, emission is really cool. If we look in the game view, we're not centered, so let's take our Crusader and zero out its position. Great. Okay. Let's take care of this glass material. So we need to take the smoothness and the metallic and turn them all the way up. Now you can see that it looks sort of reflective, but it's not transparent at all. We can't see inside the cockpit. We wouldn't be able to see outside of it. So we're going to change this to additive. And now you can see, we can see through it. It looks a lot more like glass. If we go inside it, it just disappears. This is because the render face is only set to front. So let's change that to be both. There are multiple ways you could handle switching between a cockpit, but this is the simplest way we can do it right now, quickly, where we're not doing extra coding. Let's make a new folder called Scripts, speaking of code, and make our ship controller. And we'll open this up, delete our start and update method, and dive right in. I'm going to require a component of audio source type. It's just a helpful reminder to me to add the audio source component to the ship. We're going to make a public enum called flight mode with arcade and sim. Then let's make a header for mode. We'll make a serialized field for our flight mode. We'll call this current mode, and for now we'll initialize it at flightmode.arcade. We'll make another serialized field. This will be a bool for invert pitch, and we'll initialize that at false. Let's make another header for input actions. We'll do a serialized field for several input action references. We're going to have our steer action, our throttle action, our yaw left action, and our yaw right action. Then we'll make another header for movement. We'll have a serialized float. This is for our minimum speed. We'll initialize the minimum speed at 10.
Because 10 sounds official.
And we're going to do another serialized float for our max speed of 100. Then we'll have another float for starting speed, and another one for arcade cruise speed, and another one for arcade speed change rate. And one more float for sim throttle adjust rate, which we can set at 0.5. Now let's make another header for rotation. A serialized float for pitch speed, one for yaw speed, and one for roll speed. Let's set pitch and yaw to 90, and let's have roll be a little faster at 120. Now let's make another header for speed-based maneuverability. This is what we talked about in the last video, where if we're going really fast, we want our turning to be a little more difficult. So we're going to make an animation curve called maneuverability by speed. And this will be an animation curve that uses the ease in out, and we'll have this be 0, 1.4, 1, and 0.6. And those need to be floats, so make sure you put an F at the end of them. Now let's make another header for arcade auto level. This will be a serialized float, arcade pitch return speed, we'll set that to 3. We'll have another float, arcade roll return speed, and we'll set that to 4. Then let's make another header for input smoothing. We'll have a serialized field float for steer responsiveness, which we'll set to 8, and we'll have another one for throttle responsiveness, which we can also set to 8. Let's make another header for engine audio. We're going to have a serialized field for our audio source. We'll just call it engine audio source. We'll make another float for our min engine pitch and our max engine pitch. We'll have these be 0.85 and 1.5. We'll have another float for our min engine volume and our max engine volume. These will set to 0.2 and 0.9. Then we'll have another float for our audio lerp speed, which we'll set to 6. And one last header, we'll just call this debug. We'll say serialized field range, have a range of 0 to 1. It'll be a float, which we'll call sim throttle normalized equals 0.5. Then we're going to have some private variables here. We're going to have a vector2 called smoothed steer input. That is difficult to say. And another private float called smoothed throttle input. The word smoothed is really hard for me to say. I don't know about you guys. Then we'll have a private float for current speed, a private float for our displayed engine pitch, and a private float displayed engine volume. Then we'll have a public flight mode so that we can access our current mode, and a public float for our current speed, and a public float for our current speed normalized. And this one will use mathf.inverseLerp with our min speed, our max speed, and our current speed. Then we'll have a public bool, which we'll call invert pitch to access our invert pitch. Okay, in our awake method, we're just going to say if our engine audio source is null, then our engine audio source equals get component audio source. Then in our start method, we'll say current speed equals mathf.clamp, starting speed, min speed, max speed. Next, we'll say if current mode is flightmode.sim, sim throttle normalized equals mathf.inverseLerp, min speed, max speed, current speed. Then we'll say setup engine audio. Then on enable, we're going to set up all our input actions. We'll say steer action .action.enable, same thing for throttle action, yaw left action, and yaw right action. And then we're going to do the exact same thing in on disable, but switch everything to be disable. You can just copy and paste this. Next, in our update method, we're going to say read inputs, and then we'll say if current mode is equal to flight mode.arcade, then we're going to do these arcade methods for rotation and speed. Otherwise, meaning we're in flight mode.sim, we're going to do the sim rotation and the sim speed, just like we talked about in video 1 when we were planning it all out. Let's make those methods. So we have a private void read inputs. We're going to say vector2 raw steer input equals steer action does not equal null, drop down, question mark, steer action.read value, vector2, drop down, colon, vector2.0. Then we'll say float Raw throttle input equals throttle action does not equal null, question mark. Same exact things we're doing above before, but with throttle action. And it's a float instead of a vector2, so we need to say 0f instead of vector2.0. Float steer lerp equals 1f minus mathf.exp negative steer responsiveness times time.delta time. And we'll do the same thing for throttle lerp, but we'll use our negative throttle responsiveness. Then we'll say smoothed steer input equals vector2.lerp smooth steer input raw steer input steer lerp. And we'll drop down and say smooth throttle input equals mathf.lerp smooth throttle input raw throttle input throttle lerp. Okay, let's make a private float now for get maneuverability multiplier. We're going to say float speed normalized equals mathf.inverse lerp min speed, max speed, current speed. Then we'll say return maneuverability by speed dot evaluate speed normalized. Now let's make a private void called update arcade rotation. We're going to say float maneuverability equals get maneuverability multiplier. Then we'll say float adjusted yaw speed equals yaw speed times maneuverability. Then we'll say float adjusted pitch speed equals pitch speed times maneuverability. Next we'll say float yaw input equals smooth steer input dot x and float pitch input equals get processed pitch input smooth steer input dot y. We'll make that get processed pitch input method later. We're going to say transform dot rotate vector3 dot up yaw input times adjusted yaw speed times time dot delta time space dot self. And then we're only doing two types of rotations when we're in arcade mode, so the other one is going to be our pitch. We're going to do transform.rotate vector3.right, pitch input times adjusted pitch speed times time.delta time space.self. I'll just drop that down for readability. Then we're going to say vector3 local Euler equals transform.local Euler angles. We'll say float current pitch angle equals normalize angle local Euler dot x. Float current roll angle equals normalize angle local Euler dot z. Then we'll say float leveled pitch equals mathf.lerp current pitch angle 0f arcade pitch return speed times time.delta time. Then we'll say float leveled roll equals mathf.lerp current roll angle 0f arcade roll return speed times time.delta time. Then we'll say transform.local rotation equals quaternion.Euler leveled pitch local Euler.y leveled roll. And that's it for arcade rotation. Now we'll do private void update arcade speed. For this one, we'll say float target speed equals arcade cruise speed. If smooth throttle input is greater than 0.1f, then we're going to say our target speed equals our max speed. Else, if smooth throttle input is less than negative 0.1f, then we're going to do the opposite. We're going to say target speed equals our min speed. Then current speed equals mathf.move towards current speed, target speed, arcade speed change rate times time.delta time. And that's it. Next, let's make our sim methods. We're going to have update sim rotation, which is going to start with the same principles. Float maneuverability equals get maneuverability multiplier. Float adjusted roll speed equals roll speed times maneuverability. Float adjusted pitch speed equals pitch speed times maneuverability. And unlike arcade, we actually have three modes of rotation, so we're also going to get our adjusted yaw speed and multiply the yaw speed by maneuverability. Then we'll have roll input, which is equal to smooth steer input.x, and pitch input, which is our get processed pitch input, smooth steer input.y. Then we'll make a float yaw input, initialize at 0. Now, if yaw left action does not equal null and yaw left action.action is pressed, then we need to say yaw input minus equals 1f. Then we'll say if yaw right action does not equal null and yaw right action.action is pressed, do the opposite. Yaw input plus equals 1. Next, we'll say transform.rotate vector3.forward roll input times adjusted roll speed times time.delta time space.self. Transform.rotate vector3.right pitch input times adjusted pitch speed times time.delta time space.self. And we have one more to do here with this one because, again, all three forms of rotation. We're going to do transform.rotate vector3.up, yaw input times adjusted yaw speed times time.delta time space.self. Now let's make our update sim speed method. We're going to say if mathf.absolute,
praise the absolute,
smooth throttle input is greater than 0.01, sim throttle normalized plus equals smooth throttle input times sim throttle adjust rate times time.delta time. Sim throttle normalized equals mathf.clamp01 sim throttle normalized. Then we say current speed equals mathf.lerp min speed max speed sim throttle normalized. Now let's make our get processed pitch input method, which is actually a float, which we'll take as an argument raw y input. We're going to say float pitch input equals negative raw y input. If invert pitch, then pitch input times equals negative 1f, and then return our pitch input. Now let's make our move ship method, which is very straightforward. Transform.position plus equals transform.forward times current speed times time.delta time. Then we'll make our setup engine audio method, and in there we're going to say if engine audio source is null, return. If we don't have an audio source, don't do this. Engine audio source.loop equals true. If engine audio source.isPlaying is false, and engine audio source.clip does not equal null, then we should play our audio source. We'll say float normalized speed equals mathf.inverse lerp min speed, max speed, current speed. Then we'll say displayed engine pitch equals mathf.lerp min engine pitch, max engine pitch, normalized speed. Displayed engine volume equals mathf.lerp min engine volume, max engine volume, normalized speed. Engine audio source.pitch equals displayed engine pitch, and engine audio source.volume equals displayed engine volume. Okay, now that that's set up, we'll do our update engine audio method. We're going to say if engine audio source is null, return, same as before. Then we'll say float target normalized power equals get engine power normalized, another method we haven't created yet. We'll say float target pitch equals mathf.lerp min engine pitch, max engine pitch, target normalized power. Then we'll say float target volume equals mathf.lerp min engine volume, max engine volume, target normalized power. Float t equals 1f minus mathf.exp negative audio lerp speed times time.delta time. Displayed engine pitch equals mathf.lerp, displayed engine pitch, target pitch, t. Then displayed engine volume is going to be equal to mathf.lerp, displayed engine volume, target volume, t. Engine audio source.pitch equals displayed engine pitch, and engine audio source.volume equals displayed engine volume. Then we'll say private float get engine power normalized, that method we were talking about before. If current mode is flight mode.sim, return sim throttle normalized. Then return mathf.inverse lerp min speed, max speed, current speed. Then we'll make a public void so that we can switch modes. We'll say if current mode is flight mode.arcade, set mode to flight mode.sim. Otherwise, set mode to flight mode.arcade. Then we'll say public void set mode, which we'll take as an argument a flight mode. We'll say current mode equals mode. If current mode is equal to flight mode.sim, sim throttle normalized equals mathf.inverse lerp min speed, max speed, current speed. Else, current speed equals mathf.clamp, current speed, min speed, max speed. Then we'll say public void set invert pitch, and we'll say invert pitch equals should invert. We want to make this take a bool as an argument, which we'll call should invert. Then we'll make a private float called normalize angle, which we'll take as an argument a float. We'll call this angle. We'll say while angle is greater than 180f, angle minus equals 360f. While angle is less than negative 180f, angle plus equals 360f. And then we'll return the angle. That should be it for this script. So let's jump back into Unity. And we're going to create a new folder for input actions. And we're going to make input actions. I'm going to call mine Spaceship Inputs. Jump into these, make a new input action map, which I'll call Spaceship, and make some new actions. I'm going to call this one Steer, this one Throttle, the next one I'll call Yaw Left, and the last one I'll call Yaw Right. For Steer, this needs to be a value set to vector 2. Throttle needs to be a value set to axis. Yaw Left and Right both need to be buttons. Now for the bindings, you're going to want to make a composite if you're on PC, so that you can set up, down, left, and right to WASD, for example, which is how I'm going to do it. Then for the gamepad, we'll just set this to the left stick. That should be it for Steer. Now for Throttle, we need to add a binding with a modifier. We're going to call this a 1D axis, set it to neither. And this one we're going to set to the right stick's Y. For Yaw Left and Right, I'm going to make these the shoulder buttons on gamepad. And on keyboard, I'm going to set this to both Q and E, as well as the left arrow button and the right arrow button, in case you prefer that. Now let's drag this script onto our ship and drag these input references into those serialized reference fields. There's our animation curve. And I'm going to invert the pitch. I'm going to assign this audio source. Let's create one more new folder called audio. Now I've just made a noise literally with my mouth. That is what this sound is. It's just me going and I spliced it in such a way that it loops not too terribly. I'm going to drag that in. We're going to set this to play on awake and to loop. And we should be good. Let's hit play and see what happens. Okay, so we have sound, and we rotate. You know, we're in arcade mode, so we're just able to pitch up and down, move left and right, and then it levels out when we let go. All of that's good, but we're not actually moving anywhere. We don't appear to have any speed, so let me check this. I didn't actually assign these bindings for the throttle, so let me fix that. Make this the up arrow, make this the down arrow, save that, go back in, hit play. And that still did not fix it, so it's probably an issue in the code. There's actually a few things I needed to fix. One, this smooth steer input.x needs to be negative, and then our move ship method was never being used. I forgot to put it in our update method. That is kind of important. I also forgot to put update engine audio in here. Also very important. Now that we've done that, let's go back into play and see what happens. Whoosh, there we go. Zipping away, and that is pretty awesome already. We're spinning around. You can probably tell I'm using this in sim mode. I love flying. This is very much my preferred way to play. But we've got fully working rotation around, pitch, yaw, roll, all working really well. In addition, you can see here that we've got fully working speed maneuverability. Look how quickly I can turn, and then when I speed up, it just gets really difficult to make those turns at the same speed. That's pretty awesome. There's one more thing I've got backwards here, which is my throttling. I assigned the wrong buttons. The down arrow needs to be with negative, the up arrow needs to be with positive. And now that I've done that, I should be able to push forward on my buttons and have it speed up. Yep, there we go. Yeah, I had that backwards before, so if you followed me, you would also have that backwards. Now let's add a Cinemachine camera so that our ship doesn't just fly away from us. We're going to set the ship to the tracking target. I'm going to make this a third-person follow camera. It's really helpful to go into the game mode screen when you're adjusting this because it'll do it in real time and you can see exactly where the camera will be positioned. Then for the rotation control, I'm going to make it rotate with the follow target, and I'm going to make some of these damp settings a little more or less aggressive. And there you go. We have a pretty well-functioning ship already. It sounds absurd because it's literally just noises from my mouth for the engine, but you get the idea. If you can get a cool looping engine sound, you can have it really smoothly, seamlessly pitch up and down and get louder and softer based on your engine input, which is pretty cool. In the next video, we are going to go over our plans for adding weapons to our ship, so stay tuned for that one. See you guys next time.